Hi everybody, this is Gamboa. This is the Unit 5 Practical Exam B. Let's go over it. Question 1, fill in the blanks with always, sometimes, or never. A rhombus is blank a square. Well, a rhombus is sometimes a square. If we know that the rhombus also has the 90-degree angles. A square always has the 90-degree angles, so it's always a rhombus, but the other way around is not true. A quadrilateral is blank an isosceles trapezoids. The right word here again would be sometimes. Remember, quadrilateral, all that means is that it has four sides. But for it to be an isosceles trapezoid, well, it's got to be a trapezoid. It's got to have top and bottom parallel sides, and it's got to have equal sides. So it's sometimes that. A kite is blank a trapezoid. Okay, well, remember a kite has four sides, and none of them are parallel, and two of them are equal, and the other two are equal. While a trapezoid, it has to have parallel sides. So just on the basis that this has parallel stuff going for it, and the kite doesn't, this is never. Okay, last but not least, a rectangle is blank a parallelogram. Well, a rectangle is a four-sided figure where the top and the bottom and the left and the right sides are parallel, and it's got 490-degree angles. Now, a parallelogram is a four-sided figure where the top and the bottom and the left and the right sides are parallel. So this one's actually an always. A rectangle is always a parallelogram because to become a rectangle, it needs to have started a parallelogram and then added on more specific details, okay? So there's that. Zoom in if you need so you can see it there. That's question 1. Let's move on to question 2. Question 2, can you tell me the interior angle sum of a 67 agon, or 67 gon? So as we know with these, we always take the number of sides, in this case 67. You can say that's how many sides we have. I know that if I were to break up that 67-sided figure, it would be made up of 65 triangles. So therefore, since each triangle has 180 degrees in it, I just need to count whatever 65 times 180 is. And at that point, I would use a calculator. I'm going to write the words CALC to let you know that you can check that on your own work, okay? The point of this video is just to show you how to get to the work, but you guys all have calculators then, okay? All right, moving on. Next one. Suppose the interior angle of a regular polygon is 144 degrees. How many sides must it have? Okay, so this one again says, I have a polygon, and remember polygon means a many-sided figure. That poly part stands for n, like I don't know how many sides it is. In general, a square has four sides, so it's a four-gon, it's a quadrilateral pentagon. Remember, penta means five, that's 5 sides. And so in general, a polygon has n many sides. So the way we do this is kind of draw the picture. Here's one corner of the polygon, 144 degrees. That's the inside part. And so what we're going to do here is we're going to extend to figure out what is the measure of the exterior angle next to it. Well, the exterior next to 144 would have to add up to 180, right? So on the side, what is 180 minus 144? Well, I would say what? We're missing 6 to make it into 150, so another 36 degrees. Okay? So if this regular polygon, there's this polygon with a bunch of copies of 144 on the inside, because remember regular means all that sides are the same and all the angles are the same. So if that's 144 on the inside, that means there's a 36 on the outside. And later there'd be another 36 on the outside of the polygon and another 36. And so a bunch of those 36s would add up together to make the magic number 360. Remember, that's the total of the exterior angles for any polygon. So what I'm going to do is, since I know one of those exterior angles is 36 degrees, I'm going to ask myself, how many times does that 36 degrees go into 360? And that one shouldn't be too bad, right? 36 goes into 360 10 times, okay? So that means there's going to be 10 exterior angles on the outside, making up the 360. So therefore, there's 10 sides to this polygon. Okay. Again, when you do that, remember once you know the measure of one exterior angle, we know that relation. 360 divided by n is the number of sides. Moving on. Next one, question 4. Find the measure of just one exterior angle for a regular polygon with 18 sides. So at that point, that's cake, right? I know 360 degrees is the sum of all the exterior angles. We established that before. But if it has 18 sides, that means there's 18 little exterior angles that go around to make the 360, that when I add them all up, I get 360. So therefore, I should just divide. How many times is 18 going to 360? And that, I believe, is 20. 18 times 2 is 36, so 18 times 20 is 360. 20 degrees. Okay, so this time it's the measure of one of those exterior angles, 20 degrees. 18 copies of 20 degrees is 360, okay? This one was sides, this one was angles. All right, next one. The interior angle sum of a polygon is 5,940. How many sides should it have? So I implore you to consider question 5 and question 2, right? In question 2, we knew how many sides it had. We subtracted 2. That turned it into triangles, and then we multiplied by 180 because that's how many degrees are in a triangle, and we got our final answer. This one, we have the final answer. They kind of want us to go backwards to figure out the sides. So the way you should approach this problem is start with 5,940, and let's divide by 180, right? Because I know the last step of these interior angle sum questions is always multiply by 180. So we'll divide. That one, let me see. I'll grab a calculator and figure that out. So that divided by 180 is 33. And don't jump ahead and say the final answer is 33. What we always do, remember, was we would take the number of sides, subtracted by 2, and then we multiply by 180. So therefore, what I have to do with that 33 is add 2 to it to get 35. So this thing actually has 35 sides, right? Work backwards for this problem to see that that's the right answer, right? 35 minus 2 is 33. 33 times 180 is 5,940, okay? So that's how you do question 5. Okay, now we move on to the last 2 questions. They're picture problems. The first picture problem has this big thing. First thing we should figure out is how many sides does it have? 1, 2, 3, 4, 5. 5 sides, right? So a reminder, if something has 5 sides, by subtracting 2, we know it gets broken up into 3 triangles. 3 times 180, through many repetitions, we should have down as 540. 540 is the total of the interior angles, okay? So that means if I add this, plus 3x plus 5, plus 8x plus 8, plus 4x plus 15, plus 5x plus 10, if I add that all up, I should be getting 540. So what we should be doing at this point is, let me switch up the colors here to purple. If I add all the x's together, 5x plus 3x is 8x, plus another 8x is 16x, plus a 4x is 20x, and plus 5x is 25x. So I'm going to start writing 25x plus, now let's think of the numbers now. 2 plus 5 is 7, 7 plus 8 is 15, 15 plus another 15 is 30, and 30 plus an extra 10 is 40. Okay? So if I added all of the angles together, added all the x's together, and all the numbers together, I get this, and I'm saying that always has to equal 540 because we're talking about a 5-sided figure, a pentagon, okay? So that's what I would commit to writing down on paper, and now let's go ahead and solve it. If 20x plus 40 equals 540, we can subtract 40 from both sides, get 25x equals 500, and therefore, x times 25 is 500. We can try to figure it out, but if not, let's just do some division. We'll divide both sides by 25. 500 divided by 25 is my answer in x. I think that should be 20. I'll backwards check with the calculator real quick. 500 divided by 25 is 20. That's right. Okay. So my final answer is 20 for question 6. Okay, so that's an interior angles kind of picture problem, right? Our last problem, question 7, is an exterior angles problem. Solve for x, question 7. So in this picture, we have 1, 2, 3, 4, 5 exterior angles. The way we should approach this is, I know if I add up all the exterior angles around any polygon, if it's 4 sides, 5 sides, 23 sides, doesn't matter. We always go around full circle. We know that that total is 360 degrees, right? The total of the exterior angles, okay? So what we can do is just add up things together. So I'm saying 85 plus 71 plus 44. What's that? I'll ask Siri real quick. What is 71 plus 85 plus 44?
71 plus 85 plus 44 is
So I'll write 200, right? So I'm saying this plus this plus this is 200, plus the two x's that I have, so 3x and 2x is 5x's, right? Okay, so 200 plus 5x, that's what I get when I add up all these exterior angles. And what do I get when I add up all the exterior angles? I should always be getting 360. Okay, so that's perfectly reasonable work to show how we get to our final answer. Okay, so here, to get the x by itself, we'll subtract 200 from both sides, creating 5x on the left, I think 160 on the right. X is whatever 160 divided by 5 is. And I think that's going to end up being not too big. What is 160 divided by 5?
160 divided by 5 is 32.
32 degrees. That is the value of x in this case. Okay, and there we go. That would be your practice exam B. Looking at the time of this video, it's about 10 minutes and 50 something seconds, or maybe 11 minutes. Remember, for your exam, you get half an hour. Okay, so you get almost 3 times as much time as I'm able to do it in, which is fair, right? I move faster than you guys, and that's all right because I've been doing problems like this for way longer than you guys have. But you should have, again, more than enough time to be able to finish it. Let me go over the extra credit in this case. The extra credit question here is the measure of one exterior angle of a polygon is x. The measure of one of its interior angles is 3.5x. Find out how many sides this polygon must have, and again, then give it its formal name. Is it a hexagon? Is it a heptagon? So on and so forth. Okay, so this is just like the extra credit question that we saw on the practice exam A. So let me go over how to do this as well if you want to know. So the idea is draw your picture. The interior angle was 3.5x, right? That's interior, that's on the inside. The exterior angle, that one is just x, so I'll put that here. What do I know happens when I combine the interior angle with the exterior angle for any part of the polygon? Like even in these problems, right? If that's 71 and I draw a straight line like this, that makes 180. So if that's 71, what goes in here is whatever helps add up to 180. So same idea here. The exterior angle plus the interior angle, x plus 3.5x, has to equal 180, right? Because it makes half a circle. Adding 1x plus 3.5x gives me 4.5x equals 180. Okay? And then from there, I can just take 180 divided by the 4.5 to figure out its value there. Let me ask Siri real quick what that is. What is 180 divided by 4.5?
180 divided by 4.5 is 40.
40. Okay. So the value of x is 40. This doesn't answer our question on how many sides it has. What it did tell us is that one of those exterior angles I know is 40 degrees. So what do I do now? Remember, anytime I figure out that one of the exterior angles is 40, I know that somewhere else in this picture there's going to be another exterior angle of 40 degrees, right? And somewhere else there's going to be another 40 degrees, all these little outside angles. So if I add up all these 40 degrees, all the exterior angles, remember that gives me 360. So if I want to figure out how many copies of 40 degrees there are, how many sides there are, I should divide 360 by 40 degrees, right? What is 360 divided by 40? I believe that's just 9, right? 9 times 4 is 36, so 9 times 40 is 306. Our answer is 9, and that is going to tell me the sides. This thing has 9 sides, so 9 sides. So that answers this question. How many sides does it have? 9. Give its formal name. If y'all remember, nonagon is the name of a 9-sided figure. Okay. So in this extra credit, I would give you, 3 extra credit points for figuring out that it's 9 sides. And I'll give you an extra credit point if you remembered nonagon, the name of that. Okay. Again, not a lot of extra credit, but it'll help, especially if you got everything else right. Okay. I might put something else on the extra credit, FYI, on the actual test, aka like you get another question right from the extra credit. And for that, it's again just anything that we've been going over. It could be on what's the difference between something that's concave or convex, right? I might ask you to draw on the extra credit. Can you draw me a concave heptagon, right? And again, it's the extra credit, so if you don't get it, that's fine. It won't hurt your grade. But if you do, know how to draw something like a concave heptagon, then you get more points. With that said, I hope this video helped you with knowing what to study and the problems you can expect. Again, the real exam will be just like practice exam A, just like practice exam B, okay? Same structure, same kind of problems. If you notice, this looks exactly like the other one. But with that said, have a good rest of your evening geometry. Bye.